All right, guys, today's science lesson, we're going to be doing a lab that talks about the conservation of matter. This is a very important concept, but it is super simple. Super simple. This one will not take long. Basically, we're talking about conservation of matter or conservation of mass. The word conserve means like to keep or to save, right? So if we are talking about conserving matter, we're just talking about we are saving matter or we are keeping it. And it deals with when we're measuring things and combining different pieces. So very simply put, if this marker weighs 5 grams and this marker weighs 5 grams and we combine them, how much does this weigh? Well, 5 grams plus 5 grams, this whole thing together will weigh, 10 grams. That's it. That's the whole concept. Okay? Very simple, right? The weight of one thing plus the weight of another thing equals the weight of those two things combined. Super simple. Don't overthink it. Let's jump right in. We'll talk about it. Okay, this is the work page you're going to be working with. It's called Conservation of Matter. Okay. All right. This is the work page that we're going to be working with. It's called Conservation of Matter. If it's in your science journal, it should be on page 56. Okay. This is the work page that we're going to be working on today called Conservation of Matter. If you have this in your science journal, this is the page we're going to be working on today called Conservation of Matter. We're going to look at a couple different This is the page we're going to be working on today called Conservation of Matter. So to get started, we're going to start right here at the top. Basically, we're going to look at these 6 Lego bricks. This is the page we're going to be working on today. It's titled Conservation of Matter. And we're going to start right here at this top table. So we're looking at these 6 Lego bricks. We're going to complete this row first, talking about separate pieces. Now remember, we are learning about how matter or mass will be conserved as we build something or combine things together. So first off, let's keep it simple. How many bricks were used? Well, how many bricks are here? What is the weight of the bricks? So what you're going to do, I will tell you the weights and I want you to write them all down right here. We're going to weigh all 6 bricks and then we're going to add them together All right, so this is the work page we're going to be working on today. It's called Conservation of Matter. To start out, we're going to be using these Lego pieces to complete this table. So starting out, we have all of our Legos in separate pieces, and we need to answer how many bricks were used. So count the bricks, that's where your answer goes. Next, what is the weight of the bricks? So I'm going to weigh each one of these individually on the scale. I'm going to tell you what the weight is, and you can write them down right here. So first brick is 0.1. Second brick, 0.1. Third brick, 0.1. Fourth brick, remember, write all these down. This fourth brick, written right here, 0.1. Fifth brick, writing right here, 0.1. And this last brick is 0.1. All right, so they all had the same weight. Now draw the bricks. So very simply, just draw what you see here. You can color them if you want, but it's not necessary. So you can pause the video if you need to finish that drawing. Now we're going to come down to structure. What this means is I'm going to use these bricks to build a structure that includes all of these separate 6 pieces. And then we're going to make some observations about this structure that we have built by combining the bricks. So, first space, how many bricks were used? Count your bricks, that's where it goes. What was the weight of the bricks? So now we're going to weigh the bricks as a whole structure. And this structure weighs 0.6. So write your weight right there. And then draw the bricks. So you can draw it laying down. You can draw it standing up if you wanted to. But just quickly sketch this structure that we have right here. So what this table shows us is that when we had these bricks individually, each of the 6 bricks weighed 0.1. And when we combined the bricks together, all the bricks combined together weighed 0.6. So what we're learning is that if the weight of these individually, once we combine them, the weight of the entire structure is the same as if we added each weight individually. Why is the weight the same? Because of the conservation of matter, right? This concept right here is why this whole structure weighs the same as each of these individual pieces added up. Let's go to the next part. All right, coming down here to part 2. All right, so if we have a beaker of water, and let's say this beaker of water weighs 20 grams. All right, and then, so what is the weight of the beaker of water? That's your weight. Now, what is the weight of the tablespoon of salt? So we also have a nice heaping tablespoon of salt. Okay, this tablespoon of salt weighs 2 grams. So what is the weight of the salt and water after they are combined? If we were to combine, put the water and we were to put the salt into the same beaker. So now we have a beaker that doesn't just have water in it, but now we have a beaker with dissolved salt water in here. How much is this beaker of water going to weigh? Well, we took our 20 grams of water here, we added 2 grams of salt here, and stirred it until it dissolved. even though the salt dissolves and we can't see it anymore, we know those salt molecules are in there. So the total weight of this beaker of water is the 20 grams of water plus the 2 grams of salt. And that's it. So that is the conservation of matter. The weight of one ingredient and the combined with the weight of another ingredient is going to weigh the same as those two ingredients added up individually. Let's look at one more example. So you should have used that information to answer numbers 1, 2, and 3 of part 2 here. And now let's go down to part 3. Okay, so we have a Ziploc bag. And let's say this Ziploc bag has some ice cubes in it. All right, and this bag of ice cubes, let's say it weighs 15 grams. Now, I'm going to, if we were to set this bag of ice cubes in the sun or under the heat lamp on our terrarium and wait for this ice to melt, then we would eventually get what? What would happen to these ice as we heat the ice cubes up? What's going to happen? I hope you said it's going to melt. So then we have the exact same Ziploc bag. We did not add anything to it. We did not take anything away. All we did was let the ice melt, and then we have so we no longer have our ice cubes. Now we just have a Ziploc bag of liquid water. How much is this water, this bag of water, going to weigh? Well, if we started here with 15 grams, if we did not add anything to it or take anything away, the ice will melt, and now this bag will also weigh 15 grams because of the conservation of matter. Right? If we don't add anything and we don't take anything away, even though this was a solid and this is a liquid, it still weighs 15 grams because it still has the exact same amount of matter. It has the same amount of atoms and molecules in it. So that's your information for these two. And I'm going to let you answer your reflection. This last question says, what did you notice when measuring the different weights in each experiment? Well, basically what we talked about this whole time was if we are weighing individual pieces of something and then we combine them, those weights are going to be the same. Right? Down here we weighed the water, we weighed the salt, and then we combined it, and it weighed the same as the water plus the salt. We let the ice melt, we weighed it, and it weighed the same. The basic idea you want to understand down here for reflection is that matter is conserved, or the weights will be the same whether it's in individual pieces or in an entire structure. Or the weights will be the same even if we change our state of matter. If we're not adding anything and we're not taking anything away, it's gonna weigh the same. And that's it. All right. See you.